In this video, we are going to look at Civil 3D survey points, inserting the points, creating a surface, elevation analysis, looking at the features of a surface, looking at the features of a point, and then change some surface styles, play around with the surface related settings. Now, before we begin with Civil 3D, let's take a look at an actual point file and see what a point file is composed of. The survey I have here was downloaded from an online website, Altalis, within Alberta, and we look at the columns here. There's 4 columns. The first column is typically the point number. The second column in this case is the northing, so PN, and the reason we can tell that is it's 7 decimals. Now in Canada this rings true, a little bit farther, other places it may not. Just know your coordinate system. The third column here is our easting. And again, I can tell that by 6 decimals, and I also know what coordinate system I downloaded it from. And the fourth column here is the elevation of the point. So we have point number, northing, easting, elevation. Sometimes there's a fifth column with description. So this would say something like road center line, and the next one would be road center line, and you could logically map them out. However, this file doesn't have that information. It is also saved as a CSV file, .csv, which is comma separated values. Now this becomes important when we go to insert it into Civil 3D and look at it. So I'm going to close that and just not save it. And back into Civil 3D, I've just started a blank drawing here, blank template. I'm going to go up to points, create points. And here's our create points dialog box. We have many different options of inserting points. However, the one we want to focus on right now is import points. However, let's set up the default layer first. So I'm going to dump these on c-serve-existing because it is my existing ground. And this other information shouldn't really matter, but we'll set our point, use next point number to 1, and default name format, start with 1. So just set those up so we make sure that they are proper. I'm going to click on this import points button. Then I'm going to click on the plus. So this is the import points dialog box. Now in the folder where the files are located, I'm going to select survey. This is my existing ground survey that I downloaded. So we'll hit open and Civil 3D will load it in. Down here is a preview of the survey points, the survey file. So here's our point number, what Civil 3D has termed as the easting, northing, elevation, and description. However, we do know that's wrong from the previous one. Now again, this is just a preview. You definitely have more than 20 points in this file. So knowing that this file is point number, northing, easting, elevation, we can select the correct one from the drop down or the list of point file formats here. So again, pay attention. Point number, northing, easting, elevation. More file formats can be created with this button here. However, we're not going to go through that. It's always good to get in the habit of adding points to a point group, which I'm going to name existing ground points. And then these 2 buttons only matter, elevation adjustment, coordinate transformation, if we are using a conversion. So from, say, 10TM to another coordinate system. This one happens to be in 10TM EAP, so 10TM forest right here. However, I'm just going to go with that coordinate system and we'll set that up in our drawing so we can view an air photo. So after I have that all set up, I'm going to click OK and wait until it loads. Okay, now the points have been inserted. They don't appear on the screen because they have X and Y values that are off the screen. And I'll show you what we're centered on now. So I'm just turning on coordinates. If we look at the bottom, it's anywhere from minus 133,000, minus 76,000 to 270,000, 109,000, where we're up in the 5.6 million and 560,000 range. So I'm going to zoom extents. And then we can see the points here around the 563,000 and 5.65 million. Now I'm going to set up the coordinate system for this drawing. So drawing utilities, drawing settings. You can always do this before, but I'm going to type in Cana 83-10TM115, which is a coordinate system. However, this one ends with EAP, easting always positive. So we'll hit OK. And we'll let that update. And then we have access to our geolocation. Now, if I was correct in the coordinate system, as soon as I hit map aerial, we should see a map of Calgary, Alberta here. And there we go. So here's Calgary, Alberta with the map underneath. Just to confirm they're in the right location, I'm now going to turn map off. Now, these survey points don't have any description built into them. However, it's a large chunk of land. They're all existing ground. They're downloaded from a website in Alberta. So what can we display with them? Well, if I go to the point group properties, so expand point groups under existing ground points, go to properties, we could change the point style. So let's make them existing ground and take a look at what that looks like under marker. It's just a red X. And the label style is currently on description. However, the only information we really have available is point number, northing, easting, and description or elevation, but we don't want to see all that information. So let's just look at elevation and hit OK. Give Civil 3D a minute to update because there's a good probably 100,000 points here. And now if we zoom in, we can see different elevations. So elevation 1053.5. If we look over here, 1058.7. And if we look where it's a little bit higher, 1091. So quite a range across the city here. 1042 down here, 1098. So there's a few things we can display with points. However, generally I don't show points on a drawing. So I'm just going to go back to point group properties. And again, this is another way of doing it. And I'm going to set these to back to description. I just want to see where the X's are. Even though there's no description, you could choose none if you wanted to as well. So after we have the points in, there's not much we can look at. Let's create a surface so we can see what this looks like. So I'm going to create a surface. I'm going to call it Existing Ground City of Calgary. And knowing where the location is, I'm definitely not going to use 0.5 and 0.1 interval contours. I'm going to set it to existing ground 25 and 5. So we'll hit OK. We'll hit OK. And we'll expand surfaces, existing ground city Calgary, and finally definition. However, before I do that, I wanted to look at the properties of the point group existing ground points. So we'll select that, right-click properties. Go under raw description matching, include. When we inserted them, we included point numbers with point numbers matching, and we inserted points 1 to 9,282. So there wasn't 100,000 points, there's about 10,000. So any point number matching this will be included in this point group. You do not want to inadvertently put your design points in here either. Usually when I'm talking about existing ground, I will change these point numbers to something larger that's 100,000 or bigger, because not very often will we be inserting that many points. So let's just do that quickly. I'm going to select my point number down here in the panorama window. We'll hit Control A and give it a second to load. I'm going to right click and I'm going to hit renumber. I'm going to add 99,999 to these points. So my very first one is 100,000. So I'll hit enter. Give Civil 3D a second to update here. And after about a minute, my point numbers have updated. My existing ground points is now out of date. And if I update it, there are no points in this point group anymore because they no longer match the 1 to 9,282. They will, however, match 100,000 to 109,282. 283 probably. So we'll hit OK, and this point group will again update. So now there's no way you can accidentally make a mistake here, and it was actually 109,281, but that's okay. So there's no way you can inadvertently create new points at point number 1 and accidentally include them in this group. You want to keep existing ground 100% separate from everything else. So now that we've looked at that, let's go into our existing ground city of Calgary. Let's add the points to this actual surface. So I'm going to add a point group. I'm going to select my existing round points and I'm going to hit OK. Do not double click because it will open up your point group properties. So select it and hit OK, and give Civil 3D a minute to build your surface here. Now I chose the 25 and 5 contours because if I had done the other one, we would be looking at something like this. And I'll give Civil 3D a second to update. You can't see anything. You have no clue what's going on. So back to the 25 and 5. So knowing the city, there's a bit of a plateau here. We go down the hill. This is more where downtown is. Back up to another little bit of a plateau. If we were to view this in 3D, I'm going to change my surface style, contour 3D geometry. So this is exaggerated by 10. I might change that to 2.5. Under triangles, I'm going to change that to 2.5 just so we don't view anything crazy. And I'm checking my model to make sure triangle and majors and minors are on, and they are. I'll hit OK, and I'm going to object viewer this now. So it's currently set for 3D hidden. Let's go to conceptual. And we can see some definition here. 10 times exaggeration may have been okay. However, you can see the plateau down to where the river and downtown area is, back up to another plateau. So what is this surface made of? We're going to keep in mind where these point locations are. And I'm going to go into the surface style. And I'm going to turn on triangle display. And I'm going to change the color to cyan so it's not just white and we can actually see the triangles. I'll hit OK and let Civil 3D update, and here's our surface. So what a surface is made of is basically a bunch of 3D triangular faces all stitched together. And as you can see, there's triangles, 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 and there's only ever triangles. And they're all 3D faces stitched together. And that's what gives you your 3D surface. Now, where these triangles end and start is where those survey points are located. So those survey points help define the surface. So let's freeze the survey points now. I'm just going to layer freeze them. I'm going to go back into my surface style, and I'm going to turn on the points that make the actual surface, and then I'll go under the points tab in here and make sure we can see the data point symbol, which right now is set to just a dot. I'm going to make it an X with a size of, we'll say 5 meters. So I've for sure turned it on. Yep, points, triangles are still on. I'll hit OK. Now these are not Civil 3D points. These are the points inside of the surface making up the actual surface. So we can't select them separately. They're part of the surface itself. They're related to the Civil 3D survey points, where if we delete one, this point will then remove itself, but they are not Civil 3D Kogo points. I'm going to go back into surface style and turn those points off. And take a note that we could add in user-defined contours if we had to define a water level or a flood level. We could display directions, elevations, and slopes, and we're going to do a quick elevation analysis. So I'm going to turn elevations on and turn triangles off. So leave major, minor, and elevations on and hit OK. Right now it's set for a bunch of just green 3D faces. The higher the elevation, the darker the faces. I'm going to go into the surface style again and go under analysis, elevations. And right now it's set for greens. You could set it for pastels. Again, just different colors. Pastels is a lot easier to see through. Darker purple, down to blue, down to red, lower elevation, and the reverse the other way. However, I want it to display as a hatch solid. And then I'm just hitting apply in between so we can see it update. Different elevations here give you different color banding. Now, how do we see what that banding is, those elevations of it? So I'm going to hit OK and exit surface style. I'm going to right click on my surface and go to surface properties. Under the definition tab, analysis tab now, you see there's many different kinds of analysis. So you can do a contour analysis, a direction analysis, which way are the surface triangles pointing, an elevation analysis, which is the one we're going to use, A slope analysis, different slope steepnesses give you different colors. Slope arrows, so we can see which way the surface is pointing with color and arrows. We could add user-defined contours, and we're not even going to talk about watersheds. So let's do an elevation analysis. We could choose the number of colors we want. So if we say group by number of ranges, we'll just do 8 and hit down. It's going to try and break up the surface into even chunks, so 25 to 41, 41 to 57, and it's going to grant a color scheme to them. If I hit apply here, and OK, nothing is updated because that was the default. So we'll go back into surface properties, and let's do 10 ranges. So added 2 additional colors. If we hit apply, the surface is updated. We'll do 12. And remember to click the drop down button. Apply. So we can do an elevation analysis and we can quickly see which colors are which. So what's the elevation difference? So if we go up to 18 and hit OK, it's a lot higher over here. So purple is on the higher side, 1151, whereas red is on the lower side, 1138. So, and we find over here is even higher than up over in this part of Calgary. So that was an elevation analysis with color banding. You'll generally see those on topographic maps, relief maps. Again, there's under surface style, we can turn those off and say we turn slope arrows on. Again, give this a minute to update and we zoom in. And right now it's just a bunch of red arrows because we haven't created analysis, but this will show you if a drop of water lands here, it's going to flow up. It's going to flow up, it's going to go down here, and you can generally trace along with the flow arrows of where to find where the water is going to drain. However, this is a LiDAR surface, not a very accurate one, so it's not going to give you 100% of what you want. Let's go do a slope arrow analysis in surface properties. Let's do 10. Okay, what if we type 200? 8, 5. So if we type 5, we get 5. If we type 8, we get 5. So let's see if we can change this, fix this up through the style itself. So our information tab, edit current selection, under analysis, slope arrows, scheme, let's do pastels again. Or we'll leave it on rainbows. Group by equal interval. Number of ranges 10, range precision 1. So let's do range precision. Let's try 0.01 and see if that makes a difference. Arrow length 10, sure. And we'll accept all those other defaults. We go back to analysis. We type 8, we get 8. We type 10, we get 10. So just adding that additional precision, even though it gives us decimals on our percentage here, it allows us to choose more colors. So even if I type 18, I only get 14. So 50, I'll get 24. So a little bit of playing around, but now let's hit OK. And our slope arrows should change color. Most of them are red, but the odd one you see will be, there's an orange one. Steeper chunks of land, your slope arrows will change. Surface properties, let's see if we can go up to 200. Let's see if we can expand this. There, and so typing in 200 gives 200. What about 100? So we'll hit OK. And again, most of them are red, probably because they're on the lower side of things. However, the color does change, indicating on the slope of the arrow. Now, one last thing, if we go back to the surface style, we'll turn off slope arrows. We'll turn back on elevations, which are elevation banding. Let's add a legend table. So under surfaces, add legend table. Command line's asking you what kind of table do you want. Let's do elevations. Let's make it dynamic. So if the surface changes, the table will update. And then I'm going to drop it here in model space. Give this a second to populate. And then this tells you exactly the ranges in the surface, what elevations they are, and what colors they are. Although that's showing us 100 colors where we only have, oh, elevations, I did bump it up to 100. So back down to, let's say 18 for this one. So elevations, yeah, back down to 18. We'll hit OK. This table will shorten and update and display our new colors. So that was inserting survey points, creating a surface out of the survey points, looking at the surface features, triangles, points that build the surface, and running just a couple simple analysis on that surface itself.